Containers, by default, do not give us a security advantage, nor a security isolation or a sandbox. Containers are not virtualization in a sense that we may run a virtual machine or a virtual host, and the processes within that virtual machine are separated or isolated from the other processes that we have on the host. Containers are effectively another process that runs on the host along with other processes that are running. Let's put it in a different way. When we run a Flask program or a Node app inside a container, effectively that process, or specifically that child process, runs by a parent process that is called container. And obviously this parent process will limit the world view of the child process. The child process runs along with other processes that we have on that machine. And like many other processes, this process also needs to run by a user account. And as we will see today, that user account by default in the most machines is user root. Now, when we want to look at the container security, there are three angles is important for us. One is the container registry security incident. The other one is a container daemon, vulns, and finally the many secure configuration that we may come across when we build or when we use a Docker image or a container image. Speaking of the first one, this is an incident I picked up which happened in April 2019, where there was an unauthorized access to the Docker Hub as a popular container registry. And within that incident, over 1,900 accounts, including their credentials, usernames, and hashed passwords, and in some cases tokens for GitHub, Bitbucket that was used to auto-build those Docker images were compromised. So incidents such as this just tells us that if there is any issue happen on a container registry, and if there is any malicious tampering of those container images will happen, those malicious activity may find their way inside our own infrastructure. Because by default, the majority of the Docker images or container images that we build are not built from scratch. You actually rarely find a Docker image or a container image that is built from scratch. So we always use one of those container images that are available to us through one of these container registries. Mostly it's recommended that we use some of these official container images. Now, if there any issue happen with one of those container images, those issues, those problems will find their way inside our own infrastructure. What can we do about this angle of problem? Well, keep an eye out for the incidents such as this. And one of the other recommendations here is to check the checksum for the image that you are using. The Docker images or the container images, they do come with a SHA-2 hash, which is a checksum for that, which verifies the integrity of that container image. And these days, some of the container images do come with a cryptography signed version, which is rare, but if there is a case for the image that you are using, well, signing a container image and checking for whether that image was not tampered is also a way for figuring out whether this official or the image that your container is based on has not been tampered. The other angle is the ones that are related to the container daemon, or for example, in this case, the Docker engine itself. Now, Docker has been notorious to have large number of Simlink attacks. Links or if you're coming from a Windows Word, is like a shortcut, the shortcut to different files or documents or applications that we have in our program, well, in our system. Now, this notion of symlinks is that from a container is possible to access files, directories, or different paths in the system. Now, the situation is more complex than just accessing a file, but this will allow a container to effectively get unauthorized access to some other files. And again, up until today, these problems keep emerging, and pretty much we just need to make sure to have a container image, the container DOM on that is hardened, that is well, as the latest version, hopefully without any of these issues. And finally, the area that we're gonna spend our most time are insecure or misconfigured container images. All those Docker files that we built. By default, these container images are not secure. In fact, if we look at some of the base container images, they do not come with any sort of hardening. Let me show you an example. Well, actually, I will show you an example of it a bit later, that we will see that even a base container image that we will use to build our own container image, which is based on, it's not hardened. And obviously patterns such as below, that the things that we declare in a Docker file or the container specification, a few lines of code, well, there are at least 5 security issues just within this example that I have for you here. By the way, if you know some of those, please feel free to post it in the chat so we can speak more about them. This is where I'm going to spend the most time, and today, out of many weaknesses that is related to the container, I'm going to focus on one of the issues, and that is to do with root in a container. Now, the terminology around root and not running a process as a root, I think is a bit confusing. So I want to separate two things out, just to be clear what we actually mean by running things as root in a container. So there are two things that two security weaknesses here, that they have two different treatments. One is running a process as a root in the container, and the other one is running a container as a root. So what I am talking about, let's just deep dive to the first one, running a process as a root in the container. To understand this fully, let's just go a few years back to the year of where there was no containers around. We all know that running a process as a root on our machine is a bad practice, because by the time that process gets compromised, say it's an Apache web server, it's an Nginx, or things like that, an adversary has full access on the host. Effectively, adversary has access to whatever root has access on the host. A bad thing. The other thing is around running. Now, when we come to the container world, things are similar. When we run that process as a root in a container, and this is a default behavior, effectively, if a compromise happens, that adversary has full access inside the container and some of the resources that are shared from the host that containers runs in. A bit on that a bit later. Let me show you a quick demo of what I'm here talking about. Now here I have a user called Alice on a system. I think this is one of these Linux distro. And this user, if we look at it, what groups it has access to, it has access to, well, a group called Docker and a group called Alice. And we do need these group called Docker for this user to be able to execute Docker commands or build or run containers. So let's just run a sample container and see what will happen by default when we run this container. So I'm just creating an interactive container. So I will get a shell from this container. I will just have that dash IT to just give me an interactive terminal or a shell from that container. --rm is just to remove this container once I'm finished my work with it. Here I will specify the image that I will be using. So in this case, I will be using BusyBox, a popular image which contains a lot of Linux utility tools. And inside this image, I just want to run sh. So just to get a sh shell from it. And here we go. Now we are inside the container. And one of the things, if you are familiar with some of the conventions in Linux, anytime you see hash, this means that you already have a privileged account on that system. To verify it, just hit ID, and this will verify that, in fact, we are root within this container. Now, what does that mean? That if, let's say, there was a program or a vulnerable program, adversary is able to now from here would be able to traverse through different directories on this system and able to see things that a root can see. So things even like a shadow file. The other thing perhaps is interesting for us to know, and just to highlight the fact that this root user inside our container is mapped to which user on the host is by looking at this UID mapping file within the proc self path. Is 0, anytime you will see the UID of the user ID of the 0 in a Linux system, that points out you are effectively running things as root. This is mapped to the UID of the 0 on your host. So that means a root in a container is equivalent to root on the host. Now, this is not specific to this container, just BusyBox. Say if I want to run the same command, but, well, let me pick, let's say, Python. I'm using one of the most recent version of Python, the Alpine flavor, and similar to the above, I'm just getting a shell from this container. Again, as you can see here, well, it tells me that if you run ID command, it tells me that not just root, I do have access to a lot other user and categories, but root is the most important on which I have access. If I run cat shadow, I should be able to access all the root own resources. And shadow is just one example to show that I'm root and I have access to all these resources. Now, and if I look at that again, the user mapping that I showed you before, to just verify that where this user is mapped to on the host, let's open this file. If you're wondering what this number is the number of other UIDs that are not mapped and is available within this container. So I'm simplifying a lot of things here just to highlight the fact that at the moment this root process in the container is effectively root on the host. Let's just verify this. Perhaps I will run one sample command here and just keep it running so I can verify something else along with that. And so effectively watch ls, this just keep running the ls command inside the container. I will create a new tab. I will go to a new tab perhaps here. Let me try this for a sec. And just so now I'm on the host. I'm not in the container anymore. I moved to a different tab. I have my container running in this panel here, and it just keeps running the ls command. And if you just run on a host and just type in the simple ps command. Now what you can see here, if you pay attention to this line, As you can see, this is my watch command. That is keep running that ls command that I'm running in a container. And if you just come here, you can see this is now, in fact, runs as a root. Cool. Now let me go back to the browser and review some of those official Docker images that most of the time we use them as a base for our containers. Like one of them is BusyBox. So this is like in GitHub docker-library BusyBox. If you look at this repository, is in fact the Git repo of an official image for BusyBox, the one that I just ran. If you look at inside the stable directory and muscle for the Alpine, if you look at the Docker file, there you go. We do not see any hardening or specifically any specific user that this container will be run at. That's why we have by default that root within the container. Or if I look at Python here, so again, Docker library for Python, and yeah, the Git repo of the official image for Python. And if, for example, if we look at this version 3.10, again, the Alpine distro, the Docker file, it is based on Alpine itself. It goes through installing some dependencies, and eventually here, if we run the Python 3 command, and again, we do not see any hardening in terms of any, we will see later, any restriction on the user that once you run a process within this container, effectively your Flask app or your Django app, this will not be restricted to a specific user, and by default, it will be executed as root. Okay, now let's back to our presentation and talk about the second angle which I discussed a bit earlier. Now, this is running a container as root. So when we're talking about running a container as root, we're talking about that parent process. So if our program is a child process that's been executed by a parent process called Docker daemon, or sorry, the container daemon or a Docker engine, this process itself, which runs within our host, by default run as a root. So that means that if the Docker daemon or engine itself gets compromised, well, the adversary has full access on the host as well. Now, one thing perhaps is interesting for us to know is that Docker behind the scene, it's a client and server, service. So anytime you run Docker command behind the scene, there is a HTTP or a REST request over HTTP. It's sent to that Docker daemon or Docker engine that runs on your machine. So by default, that is your local host. So that means that if there was any malicious container or if there was any other vulnerability that adversary could exploit, it could result into root on the host. Just to verify it, and this is perhaps interesting for some of us, that effectively by giving someone access to run Docker on a machine, or not just someone, by giving a process or a program access to run Docker, and that is the Docker client command, or access to invoke that HTTP API, which belongs to the Docker daemon or the container engine, effectively we have given them root access on the host. So just to show this fact that as a user on this machine, I do not have access to, obviously, to the root resources. So for example, I cannot go ahead and open the shadow file, permission denied. But as you can see here, this user does have access to Docker group because we can run Docker command. Now, I can do something else. I can invoke the Docker command just to run a container here, similar to before, but with a bit of twist here. I want to do a volume mapping and try to access some of those resources that by default I don't have access to, in this case, shadow file. This again, and map it to one of the passes within that container, and I can call it anything that I want. Again, the image would be busybox or any other image that by default runs as root. And now, as we know, I'm rooting the container, and I'm able to not only read the shadow file, which is the shadow file in the container, but also this mapped shadow file from the host, which in this case, which in this case is this file. Let me run that again. So what I did here was that I just ran ID just to verify that this was the group that this user is on the host. This user does not have access to root own resources. Just to verify it, shadow file, permission denied. But since this user has access to Docker, we can bring up a Docker container, and here we just do a mapping of that file that by default I don't have access to, and then map it to any pass in a container, and eventually getting that busybox and shell. And now inside the container, since I'm root, and we already know that the root in a container is root on the host, just to verify that as well, self UID map. Sorry about that. Yep. And now I can not only read all the root-owned resources within the container, I can also read those shared resources from the host because I'm root in a container. And why this happened is because by default this Docker engine or Docker daemon that I'm running on this machine runs as a root, so it has access to all the root resources, and that can nicely prepare all these shared resources for me inside the container. Okay, so not a good thing. What can we do about it? Now, I want to actually take this a little bit further and go through one lab. And these labs are quite interesting because we start with a scenario where there is a program that is vulnerable to something, and the attacker is able to run remote commands or arbitrary commands within that container that this program runs on. And I have kept all the default settings typically when you run a Docker image. And we're going to see how far an adversary can go by having this condition. So to do this lab, you should head to learn.secteam.com. And the first thing you may want to do is go to the sign-in. If you don't have a user account, you can create one. Otherwise, log in using your existing user account. If I remember my password. Yeah, seems I do. And then, once we logged in, hit on Docker and go to root and ImageTragick. You can go straight away and click on, anytime you see this icon, this means that this is a lab that you can do it locally on your machine. Hit on root container. This is the lab guides that I will be going through. Hit on download right here, and you will be given the git clone URL of the lab. Just copy that, go to your terminal, and I think I have already cloned this directory, yes. So let me clear this out. cd docker and root, here we go. So what do we have in this lab? We have a Docker Compose file, which, as you know, Docker Compose contains those arguments and that will be passed into the Docker command at the runtime. So when we run a Docker image, a Docker file which defines the image that I will be using, a make file that just to simplify a number of commands that I want to run. A source directory and a test directory. So a source directory contains the program that is intentionally vulnerable to something. And a test that, there are a number of tests that will test if we have managed to successfully harden this Docker file. So this was just an overview. I will start by opening up the Docker Compose file. Let me open this up using Vim so it's more syntax highlighted here. So what we have here is we have a service called root, call it anything, which will be used, the build, which will use that Docker file that we have inside the container, inside this directory. And it does some volume mapping. It will map the etc shadow to temp shadow inside the container. It sets it as a read-only. This is just an example just to show that if there is a root-owned resource mapped to the container, what will be happen if there was a compromise happen in that container. Now, again, this is a very trivial example. In some of our other labs, we have examples of if we have a device that is mapped from a host and from the host to the container, and it's similar things happen in that sense. This is just to show that if someone managed to get root in a container, and if there's any shared host resources in that container, they can do quite a lot of damage to the host as well. So the goal of this lab obviously is not going and removing this shadow file as it is highlighted here, and eventually it's a port mapping which will open port 8080 on the host and maps it to the port 8080 in the container. Now, let me quit this one. And let's open the Docker file as well. Docker file is based on the image that we have already made it available with all the dependencies required for this specific vulnerability. So I will talk a little bit about this later. And it goes and copy whatever I've got in the source directory, that program.py in the container. It exposes port 8080 and eventually just runs that program.py. Okay. So what is that program.py? Let's just open that as well. Now, well, if we just skim through it, the goal is not really in this lab to just understand what this program does or to fix the security issues within the program. It's just to give us an overview. This program effectively is a Flask application, and it has a mapping for root, and which will look for post and get request, which we will see later, and eventually it will show that. So effectively, it shows an upload, a form that you can upload the file. That file will be processed by that library, by library that I will talk about it a bit later, and eventually will be shown. Okay, so let's just, first of all, what we do, anytime you got one of our labs, you just press make build. This will go ahead and build that Docker image locally on your machine. The next thing we want to do is to hit make run, and that will bring up that Docker container. So as I said, it's a Flask application, is now listening on port 8080. Let's head to the browser and open that up. Yeah, I know what's happening here. I don't have it on this machine. Let me go back to the terminal. I will just use the kale command to communicate with it. So do I have kale here? Perfect, I do. So localhost, just to verify that I can view that program right there. All right. So the vulnerability that this program is vulnerable into is known as ImageTragick. Let me go back to the browser and just bring that up. It's a vulnerability related to a library called ImageTragick, which is a popular library used by a number of languages for converting, for reformatting the image files, to resize them, to blur them. A lot of times when we effectively use, for example, some of the Python libraries behind the scene, it actually use ImageTragick. Now, this vulnerability got a very interesting name due to the problem with this. And it's called ImageTragick. It's a very memorable name. And effectively, this vulnerability is within the way that the parser of image mapping will go and parse that specific image file format. And it doesn't perform relevant, necessary validation on that file, and eventually result into code execution given a specific crafted image. So that means that if we are using a program that behind the scene uses this library, in our case, if I go back to terminal here, if I again open up that file, let me go back to here. So this program, again, let me open up with Vim. This program here is using this. Once it receives a file, it will save this file and then it converts this file. And this convert command is running a shell on that system using convert command. And as you may know, this convert command is a Linux command that will use ImageTragick library. And effectively what it does, it just takes this file and generate a PNG format of the file. So whatever format of the file that we can give to it, and it accepts these extensions, it will just convert it to the PNG and return it back, and eventually it will be displayed. Okay, now let me run this again, and this time I will try my best to open this up in the browser. Just give me a second to find the IP address of this. Machine that I'm running on. Okay, all right, let's go back to the browser. 192.168.58 and port 8080. Let's see if I can find out what's this. Yeah. 168.58 and port 8080. There we go. So we got the program here. So effectively, you need to go and choose a file. Now, what file? This is a part I will leave it as a fun and interesting exercise here. Effectively, you need to, if you go through that ImageTragick documentation, you're going to easily come across with an example proof of concept how to test or exploit this. So let me just pass in a file to this program, and I'll just find where have I saved this file. Right. Let's just put it here. Okay. Now the first file that I'm going to use is, it's going to run whoami command if it successfully exploits the system. Let's see. The request does not come true. Most likely it's because, let me have a look at the source. Yeah, it's all good. Now, if you now head to the terminal here, so the image file that I gave it to this program, it ran this whoami command on that box. So you can see the output of the whoami command here as root. Now the next file that I'm gonna run is, as we saw, let me go and again open that Docker container. cd learn docker, not the Docker file. I want to look at the Docker compose file. We know that this, we have a temp / shadow here, which is mapped whatever from etc shadow. And over here, so that means I'm now, if I'm root in the container, I would be able to access that temp shadow. The other thing we already know that when we run the whoami command, we just find out that yes, we are root in a container. So that means I can access all the root resources within the container, including that shared temp file, shadow file. All right, so this time I'm gonna run effectively same command, but this time I'm just changing that image file to dump that shadow file from that pass. So effectively catting that /temp /shadow. Going back to the browser, choose a file, and let me save this again. So save this file. Yeah. Let me save as a different file here. And there we go. Convert. And now, if we go back to the terminal to see if our command was executed, so you can see indeed, if you look at the std out here, the command was successfully executed, and I was able to get access to that temp shadow, which is a shared resource from the host, just because this program was running by default as root. Okay, so what can we do about it? This is where we want to talk about some hardening tips. The goal of this lab is that without touching the vulnerability itself, so going and fixing or perhaps upgrading that ImageTragick library or using a way better design of that program, that we are not relying on a shell to just do a conversion of the image, is by just looking at how we can harden the container itself to minimize the extent of the attack. So not so much going and fixing the root cause, which is that program, relying on that library, is by effectively hardening the container to just limit the extent of an intrusion. So obviously, a classic way to fix this is to do not run that process as root. And how we can do it in Docker? Well, quite simple. Let me go back to the terminal. And this time, I will go and open that Docker file. And right before the entry point or a run command or a cmd command, I will provide this instruction, which is called as user. The instruction user means that it will effectively downgrade to the user, or will use the user from there on for any command or run or entry point commands. So effectively here, you want to give it an existing user. In this case, I will give it an existing user, which is called 1337, and a user group. So it's UID and a GID. Now, if we save this and build this container again, and this time will be run. So that entry point that we have this time hopefully will be run under the context of that other user 337. Okay, let's go back to our page. Yep. And this time, again, let's just use this whoami. If I come back here to the terminal, the std out at the moment is empty. This is because that UID, there's no name for that user ID 1337, so whoami does not even return anything. Really good. Now, if you go back again to the browser, and this time choose that dump shadow file, this is effectively catting that /temp shadow. Hit on convert, and we hopefully gonna see a nice permission denied. Yep, and the std error, as you can see, permission denied. So this is one way that we can go and fix this issue within the Docker file. Obviously, another way that we can fix it is to supply that user, because often we may not even have access to this Docker file. Say I'm just using one of those official Docker images like Python or BusyBox or Node that by default they run as a root. And I can't really go and, unless I create a Docker image based on those, if I just want to simply run one of those, and I wouldn't be able to inject this user instruction within those. The other way to do it is obviously to modify the Docker compose file. And similar to that, we effectively here, we want to provide that user command here. And this will have the same effect as the other one that I mentioned. So that's kind of at runtime, I am mapping that user. So let me just go and get rid of this here, just to verify if things work. Yeah, perfect. So I need to go and fix this, make it as a string. Again, I'm not going to remove any of these, so just keep it as it is. And make build, make run. Okay, let's go back to the browser, refresh. Choose a file, who am I? Convert. And as I expect, same behavior. std out is empty, std error that cannot find a name for that user ID 1337. Again, going back to the browser, choose a file, dump shadow, convert, going back to the terminal, and we expect std error, temp shadow, permission denied. Perfect. Is that all? No. Is there any other way we can fix this issue? Yes, and perhaps this is one of the better ways or better practice to do that, is to have the Docker daemon or that container engine to run as a rootless or as a non-root user. Now, fortunately, at the time that I'm recording this, there is from version 19 onward of Docker, there is a thing called Docker rootless that is around. This effectively will run the Docker engine itself under a non-root user. And this means whatever container that we run, regardless whether we define that user instruction within a Docker file or the user runtime within a Docker compose file, whatever container runs, it will be executed under the privilege of these non-root user. Now, I'm not going to the detail of how we can set this up. Now, from version 20, effectively, this is a feature that we have on most of at least Docker engine. And it's dramatically reduces the extent of the vulnerability just by mapping the users, even the root user inside the container, to a non-privileged user on the host. This is a very similar feature to user namespace remapping. Now, some of you may have been familiar with this. Prior to version Docker 19, the only way we could have by default the Docker engine to not run as a root is, the containers to not run as a tool was to do a user namespace remapping, meaning that whatever you remember when I was doing cat/proc, when I was showing the UID mapping, that with this user remapping, we effectively mapping every single user within the container to another user or another non-root user on the host to get a degree of security there. Now, the rootless Docker rootless does have a number of other security features more than a simple user remapping, which is a lot better, but it also may have some usability problems which also it can bring. So just to recap that what we talk about, the best way to protect against this sort of attack or effectively root in a container or running a container as a root is a rootless mode. So if a user in a container is root, and if the container engine or that daemon runs as a root, we have quite a bad days. That is like the most extent of a vulnerability or a bug exploitation of that could be resulting into quite a severe security issue. And if the user in a container is a root, but the container engine run as a non-root, this is a case that, as I said, we have the Docker daemon or the container engine run as a rootless, or there is a user remapping that is done, that whatever user in a container will be run as a non-root on the host. And that will give us a medium severity, meaning that still a compromise will allow an adversary to access whatever, to have a full access within the container. And finally, the best practice is that to run user in a container is a non-root, so we use that user instruction. And the container daemon itself is also non-root. That is effectively the best practice and is a very low severity. If a bug or problem happen, the extent of the attack is very limited. Again, just bear in mind that by default, we are on this level, meaning that the users in a container are root and container engines are run as a root, and that is perhaps the worst situation. Is that all about the root? Are we now safe with effectively running programs as root in a container or running programs under higher privileges in a containers? Is not all. There are a few, at least two other cases that could result into a program inside the container get elevated privileges, even when we have things set up as non-root and non-root. It's a rare case, but it can be possible, and which I will leave it perhaps to some of our future workshops, or if you happen to attend our DevSecOps trainings, we do cover that as part of that workshop. Well, that was all I wanted to talk about. Let me now move to the chat, just to see if there has been any questions asked. So are we able to watch this again? Of course, everything will be recorded and is available to you after this live cast. And if you want, I can even move back to that example I had and perhaps just go through a few problems here that I mentioned. There are at least 5 security weaknesses within this definition of the Docker file. Perhaps one of the most notorious one is on the top, that obviously you do not want to base your Docker file from an image that is not official or is from someone else's image. Because if they have changed something in there, that will effectively impact the security of your own Docker file. One of the other one potentially you may spot is this expose 80, right? So to be able to expose a port, anything below 1024, we need a privileged account. So that tells me that this Docker engine that this Docker container will run as a root. There's also no user instruction. Okay, so I will leave you with these two. If you have more questions, you can post it on our Discuss platform by just heading to discuss.secteam.com, and we can answer your questions there. I hope you enjoyed it, and I will see you at our future free